Sometimes that messes it up.
So today we're going to finish that up, and then we'll get into radical functions and expressions. Here is the one, this is the one we're working on now. Looks like this. Everybody see this one? Is this one? I'll put it up on the board. Sorry, that one's a little bit
Thank you.
Unit 4, radicals and exponents, right?
Yes. It's like this. There we go. Okay. All right, so remember we went over all the rules.
I was wondering if we could get one of those.
Yes. Want to hand up?
Yes.
Then we do the rest of them too. This one. The last one I go for is the one we need now. That one. Okay.
Thank you.
Welcome. All right, so remember we have the product rule, right? And whenever you have a number, just a quick summary. Oops. Summary. The first one is, for example, 3 to the second times 3 to the fourth is the same thing as 3 to the sixth. Right, you just add the exponents. Good. Power to power. 3 to the third to the second. It's the same thing as taking whatever's inside of here, multiplying by itself twice. Right, so it's 3 to the third times 3 to the third, which we all know is 3 to the sixth, because of this rule right, the rule right above it. So power to power, you multiply it. So if it's base, the same bases, and you're multiplying them by each other, you add their exponents. If you're raising one to the other power, that's when you multiply. Good. Okay. And then the other one that sort of goes hand in hand with this, the quotient rule. With that, I think everybody sort of knows if I have 3 to the first, 3 to the fifth over 3 to the just 1 3, right? You subtract the exponents, right? Because this is 3 times 3 times 3 times 3 times 3. This is just 1 3, and remember we talked about 3 over 3, that's just another form of 1. That cancels out, so you're left with 3 to the fourth. That's
If there's an imaginary 1 on the bottom.
Yep. Right, so these are sort of all the different things. And then we also talked briefly about how any number to the 0 power is just 1. Remember, I think I talked about before how x to the second is 1 times x times x. X to the first is 1 times, because remember multiplication, addition you always start with an invisible 0. Multiplication, you always start with an invisible 1, because our multiplicative identity is 1, but number times itself is 1, any number times 1 is itself, so it always starts with 1. So x to the 1 power is just 1 times 1x. X to the 0 is 1 times no x's at all. Good. And then as a reminder, x to the negative 1 is 1 divided by an x. Which leads us to this part right here, right? It's just x to any number to the negative power means you divide by x to that many powers. I'm sorry? That's this one here. I circled in pink also. So the ones in pink are the ones that apply to the stuff in pink.
X to the negative 2 x to the second?
Yeah. So x, if you have a negative exponent on the bottom, you can move it to the top, and vice versa. So as a reminder, right, if we have a to the second power, let's do this, a to the negative 2 on top, and b to the negative 3 on the bottom, I can move this to the other side, and remove it. If I move it to the other side, I can remove the negative exponent. Because this says divide, so if I move to the bottom, then it's being divided by. Right? This says the same sort of thing. So if you move it to the other side, then it'll become positive. So this goes a to the positive 2, b to the positive 3. So if I were to simplify this, this would be the simplification. Anytime you have a negative exponent, move it to the opposite side. Right? If it's up, move it to the bottom. If it's on the bottom, move it to the top. Because it's saying I'm dividing by b, but if you're dividing by a fraction, it's the same as, it's a little complicated. But we'll stick with this. Good. If you want to know why, we can talk about it after class. So I think those are the main ones. Where were we at? We left off partway through. Did we do number 3? Did we finish number 3?
We're still on 2.
We're still on 2.
Okay.
2F, I think. Yeah.
This is going to be troublesome. Appears to not be coming in, and I don't know why it's not coming in. Try it again. Oh, that one works. Okay, great. So I feel like we left off at, I feel like we might have done D and E.
We did.
Okay, great. So we have F.
That's where we left off.
Perfect. So let's take a look at X. We're going to rewrite this in radical form. That's all it's asking us to do, is rewrite it in radical form. So think about what's on top, what's on the bottom. As a reminder, this one here, we said, okay, the 2's on the bottom, that tells you what kind of root it is. So it's going to be this kind of root, the little 2 in there. Of course, if it's a 2, you can always leave it out because it's understood there's a 2. Right? Just like we know x to the 1 is really the same thing as x, you can leave out the 1 if you want. Same thing's true with the square root. There's kind of an invisible 2 there no matter what, so you can leave off the 2 if it's a 2. And then inside we have 9 raised to the, remember this part's on top, the 3's on top, 9 to the 3rd power. On the bottom, we have the same thing. 100 to the 3rd power.
Oh, like that?
Yeah. You could also, remember I gave you 3 options. You also could have done the whole thing together. Or you could have done it the whole thing like this. That's the whole thing in parentheses, and done it like that. Any one of these 3 will work.
I got the last one.
Yeah. So any one of those is fine. Okay, but now, that's a good review. You folks do F. F, G, and H. All right, I feel like people are looking a little drifty. Okay, so remember the here. So I have, I don't know, 7 raised to the 5/3. This bottom part, that tells me what goes inside of this here, what kind of root it is. If it's a 3rd root or a 2nd root or a 5th root, whatever, this number goes on the inside that little radical. Tells you what the root is. It's your 1 over whatever that is, 1/3. This part, the 5, that stays inside with the 7. Or it could go on the outside too. You can also do it this way. And the whole thing to the 5th. Either one of those works. The 5 can go either on the inside of the 7 or it can go on the outside. They're the same. Okay, so try to work on. All right, so for whenever you have a negative exponent, straighten out the negative exponent first, maybe. So make this
Remember that if I
1
have
over
numbers on the bottom, they kind of
x to the 5 halves. And then it's just like what you had over here, only it's on the bottom.
This stuff, flipping it around. Like when
Yeah.
it starts
Same thing with this one here. We do the same thing.
getting-
Same with that one there. Same idea.
Are they doing I, J, and
Yeah,
K?
just up to H
Okay.
for now, but I'm just saying for
You're good.
future.
Oh.
Wonder how long it's been off. Wonder how long it's been off. Okay. I'll try explaining this again. So the 2's on the bottom, it goes inside of the crook. So then we have x to the 5th on the inside. G is the same, only since it has a negative exponent, first you move it to the bottom. I'm just talking to the people at home. You can ignore me. And then you do the exact same thing. Like choose inside here, x to the 5th is inside the square root. Where it gets a little more complicated is I and j. So because that 2/3 only applies to the 3, then the 5's not included. The 3's on the inside, and then inside of the square root is the 3 to the 2nd, and then 5's multiplied in front. This one's really similar, right? This raised to the -1 power means that instead of, well, x to the 2nd means 1 times 2 x's, x to the 1st, 1 times 1x, x to the 0, 1 times no x's at all. X to the -1 means you divide by x instead. So raised to the negative power means you divide by it instead, you move it to the other side. So here, the -1, we're going to move this to the other side. And then you folks are going to clean up this part here. This one, again, the negative exponent here means you're going to move it to the other side. So has everyone worked on k yet?
Mhm.
Everyone move k to the other side. Move it to the other side right now. And we'll double check and make sure that everyone's on board with that one. So k, take this, move it to the opposite side because it's a negative exponent. So when I'm going to make it a positive, if it's on the bottom, it goes to the top. If it's on the top, it goes to the bottom. Just hop it from the top to the bottom or vice versa. So I'm going to take this one, hop it to the top. Give me a little wave when you've done that. Kelly, have you done it yet? David? Okay, so have you done it yet? Move to the top. Okay, so it should be 2 times x to the 5/3 on top. You can put it over 1 if you want, but it's already, but once you have it over 1, the same thing is just, you can just ignore the over 1 part. Does that make sense for folks? Right, so you can have it over 1, but that's really the same thing then as 2x to the 5/3. Now, let's get back to this one here. So x to the 1/2, how would I write that? Well, it's still on the bottom, right? So the 3's on top. What's on the bottom? X to the 1/2. How do I write x to the 1/2 in square root form? Square root of x. Good? Thanks. Perfect. Next one over here. What's being raised to the 5/3? Just the x. Everybody on board? Yes? No? So this one is just as easy as simplifying that one up there, f. It's just like f. The only difference is you have a 2 multiplied in front. It's very similar to f. Right? So everybody clean that one up. So x to the 5/3. What goes in the little crook? It goes inside my little crook?
3.
3. And then inside the square root symbol goes the
5.
x to the 5th. Good. And don't forget, in front I have 2 times that, so 2 in front. Hey, folks, eyes here for a second. Make sure that you put this fellow right inside the crook so I don't confuse it with you multiplying something in front or something like that, because that happens all the time. So make sure you keep it right inside of here so it's really clear that that goes in there. It's not 2 to the 3rd or something like that. It's not being added onto this or something else. Good? Questions?
I'm just, see how this one was a fraction, but it ended up being multiplication with the 2 in the front,
This one?
and then the
Yeah,
previous one.
it's over 1.
Yeah, so why is it multiplication though at the end?
The two is on top. It's over 1.
Yeah, I know, but the final answer, there's a 2 in front of the whole radical.
Because there's a 2 here.
But on this one, this ended up being division.
But it's still okay.
You know
So
what I
this
mean?
is, let me show you. This is the same thing as 3 times 1 over the square root of x. They're the same thing. And this is the same thing as 2 times the root of x to the 5th over 1.
Oh.
So, yeah, this came from a fraction, but since it's over 1, you just leave it alone.
Oh.
Right? There's nothing, once I move this to the top, there's nothing on the bottom, there's just a 1 on the bottom. So whereas over here, there's nothing on the bottom, but I need to move this to the bottom. So when you have a negative on top, on one side, you need to move to the bottom. This means that really you should be dividing. This negative 1 says like this. This really says divide by an x. So this really isn't. This is really dividing. All right, same thing. Negative on top really means dividing. Negative on the bottom really means multiply. Does that make sense? Because it's on the bottom. This means multiply on the top part. So the answers are this one and that one. All right, so let's take a look at simplified expression by hand, not using a calculator. So I would say get rid of the negative exponents and then see where we are. So I'll do the second one. I'll do B. So B, I want to get rid of the negative exponent first. So take care of the negative exponents first and then simplify. So if I take care of the negative exponent, what does this become? It's on top. Where should it go? How do people feel about that? Give me thumbs. Got it? Yeah, not so sure. Completely confused. I need thumbs from everybody. We'll wait here until we get them.
Oh, it's still 1/3. It's not 3 1s.
Okay. So anytime you have a negative exponent, remember the last slide I just did, negative exponent means you divide by it instead. So if it's a negative exponent, you can just move it to the opposite side, right? You divide by this instead, it goes to the bottom. Likewise, if it's on the bottom, negative exponent, you move it to the top. That's what that negative exponent means. It means move it to the other side. So that's all I did. I just moved it to the other side. I divided by it. You're dividing by negative exponent. Same thing as dividing by it. Move it to the. If it's on top, move it to the bottom. Okay. Because so does that mean what 64 to the third? What multiplied? So to the third power means it's something you multiply by itself 3 times to get 64. What do you multiply by itself 3 times to get 64? And remember, I'm only going to give you basically 5 options. 1, 2, 3, 4, and 5. So 1 multiplied by itself 1/3, right, means you need to multiply by itself 3 times, because I'll go back to that. Okay, the 1 power means what multiplied by itself 3 times would give me 64 to the 1 power, right? Because when you multiply on the same basis, you add the exponents. So this means something multiplied by itself 1, 2, 3 times gives me 64. So what multiplied by itself 3 times gives me 64? That's what this 1/3 means. It means I need 3 of them, because it's 1/3. So what multiplied by itself 3 times gives me 64? Try it. What's 1 times 1 times 1? 1. Okay. What's 2 times 2 times 2? And we get your calculator out. 2 times 2 times 2. Try it. Okay, I want to try 3 times 3 times 3. Everybody do it. I need an answer from everybody. Did you get it? What'd you get? Okay, try. Deja, did you get it? What's 3 times 3 times 3?
47.
Great. What's 4 times 4 times 4?
64.
So that's what we're looking for. What's the 3rd root of 64? 4. So this is going to be, it's still under on the bottom. Instead of 64 to the 3rd, I'm going to write 4. Yeah.
Have you shown factorization trees yet?
No, not yet. I'm going to get to that next.
Okay.
Next one, but with the cube roots, we don't have to, because it has to be the same number by itself.
Yeah, that's true.
Yeah. So when we get to the ABCs and the squares, yeah, we'll do that.
Just because that's always how I find it. I have a hard time memorizing them.
Well, and the thing is, I'm only going to give folks one. We're only going to give people 1, 2, 3, 4, 5. There's only going to be those 5. So it's just.
Yeah, I guess I never really noticed that before. I see those numbers technically.
Yeah. Okay. So everybody do A and C. And let's do. I'll do E also. Let's do E now. Has anyone finished A yet? What's A? Do A. If you've done B, you can do A. Okay, what multiplied by itself 3 times gives me 64? David, what'd you get? 4. Perfect. Okay, C. Has anyone did C yet? Negative exponent, move it to the other side. And then solve it. Okay, if I move it to the other side, I get 64 to the 1/3 on top. So but I already know 64 to the 1/3. What's 64 to the 1/3?
4.
4. 4 over 1, which is just 4. Great. Now let's take a look at E. All right, so this is not a negative exponent. It's a negative 8. It's not the same thing. What's being raised to the exponent? The negative 8 or just the 8? Just the 8. I'm going to take a look. This is negative 8 to the 2/3 with parentheses around it. This is just the 8. Only the 8 is being raised to the 2/3. The negative is like a negative 1 being multiplied in front of it, just like we had the 5 earlier. So only the 8 is being raised to the 2/3. So we'll have negative on the outside, and then you have your little this part here. What goes inside the crook? 3. 8 to the 4th. So, third, sorry, my bad.
8 to the second.
Second? My bad. I'm all over the place. I was trying to think about if there's an easy way of doing this. Might be an easy way of doing this. Let's try this, hold on. Well, you can leave it that way. So if we did it this way, what's 8 squared? 64. So what's the cube root of 64?
8?
Cube root of 64, we found it up here,
4.
4. Another way of doing it would be, we could do 8 to the 1/3 squared, because power multiply. So you take the top, we can take the top part and put it on the outside and leave the bottom part. Or we could do it,
Oh, yeah, that's what
yeah.
I was gonna.
Sorry.
4.
So what, or we could write it as the other way around. We could do 8 squared to the 1/3. It kind of depends upon what's easiest for you. So I guess the question is, do we know what 8 to the 1/3 power is? Do we know what the cube root of 8 is? What multiplied by itself 3 times gives me 8? 2. So this is just 2. So this one might be easier this time. So we'll do that one. Not to do too many things. So -2 squared. What's 2 squared? 4. Yep. So those are 2 different ways of getting to -4. You can either switch it into a radical, if you're more comfortable with the radicals, or you can switch it into the fraction to a power to power. Okay, so everybody do D, and then do F. Oh, and G, you can do G too. That's just a times. This is really 5 times that. That's what that's that little box. It's just a multiplication symbol.